All right, everybody, we are working with the fundamental theorem of calculus today. So just a quick reminder that if you see this expression right here, where we're taking a definite integral from something to x, and then we're asked to take a derivative of that equation or that expression, this x is going to get plugged in for t, and we do not actually take a derivative of the inside here. Right, the derivative is going to cancel out this antiderivative. And so this is our fundamental theorem right here. And we've already reviewed this, but what we haven't reviewed is when the bound is not just x, but something like 2x or x squared or some other expression or polynomial or something right there. So if we're given this equation right here, capital F of x is equal to this, and we need to get the derivative. Okay, we're not going to take a derivative of f, so we just leave that as f, but we take the 2x, and it goes right there on the inside. The one big difference is we do, after that, multiply by the derivative of the inside, which would be 2. All right, so this is our derivative here if the upper bound is not just x. All right, another example here is that if capital F of x is equal to this, all right, so now the upper bound is x squared. Again, if we have to take a derivative, I'm not going to take a derivative of anything in here. I'm just going to take x squared. I'm going to plug it in for both t's right here. Plug it in right there. Excuse me, fighting off a little cold. So again, take x squared, plug it in for both t's. And that's going to give us sine of x squared, which is going to be cubed, minus, where there was a t, I'm going to plug in another x squared. Okay. The last step here will be, because it wasn't just x, we multiply the entire thing by the derivative of x squared, so times 2x here. There are a couple things we could do. We could multiply these two exponents because we have a power to a power. We could also distribute the 2x. If we did both of those things, the first term would be 2x times the sine of x to the 6. The second term would be minus 2x to the third. Right there. All right, so that's it. That is, depending on what book you're looking at, part 1 or part 2 of the fundamental theorem of calculus. And again, this shows up pretty much every year as a multiple choice question. All right, guys, that's it. Stay flawless.